Lesson 40, constructing regular polygons. Actually, it should also say in this title, within or inside a circle. Now, if you don't have in front of you already, pencil eraser, calculator, and I will also need a ruler for this lesson and a protractor for this lesson. And I know some of you, how wonderful you are about having your supplies, but you really can't do this lesson and the next lesson. Actually, you're going to need your compass also. So make sure you have your supplies ready to go. A regular polygon is equilateral and equal angular, right? We know what that means. All the sides are the same and all the angles are exactly the same. If they weren't, we couldn't do this. This means all sides and all angles are perfectly congruent. We should know what the word congruent means. In order to do so number one, in order to do the construction, divide the circle into the number of sides corresponding to the polygon. Okay, so that just means if I'm going to draw, okay, I'm going to start easy here. So we're going to do the triangle, equilateral triangle, right? So we're going to do the triangle. Let me just erase that. Okay, so n is equal to 3, and I'm going to look at the triangle. So I do want to sketch this perfectly inside of a circle. So what they're telling me to do is divide the circle into the number of sides corresponding to the polygon. That's easy. So what's going to happen here is that we're doing this. And this circle, which is a terrible circle here, is going to be divided perfectly into 3 sections. So really I'm doing 360 is my circle divided by n, which is 3. I get 3 equal 120 degrees. So I have this is 120, this is 120, and this is 120. So I have to have that easy concept, central angle. And there's a nice easy formula for that, right? 360 divided by n for central angle. That is not the same thing as interior angles. Common mistake. This corner plus this corner plus this corner, we know for a triangle is 180. Those are interior angles. That is not central angle. To find the angles of a regular polygon, you need to know the following. So we did triangle, okay? So if we're talking about to find the angles, not central angle, like I just mentioned the triangle, right? So I know that any triangle is 180, but if it's a perfect regular shape, I can easily divide by 3, and I know that every corner is a perfect 60 degrees. Same thing, right? If I'm talking about a pentagon, I know that that is n is equal to 5. Maybe you can even sketch it. And I'm emphasizing that it's a perfect one. I know that in there I have perfectly 5 equal isosceles triangles, but I do have to be careful. I do have 2 different kinds of angles happening. I have central angle. Central angle is 360 divided by 5 of them, like slices of pizza. I have every central angle is 72 degrees. So that's your middle one. Compared to, if I'm looking at the angle of one interior angle, not the total angles, interior angle, the corner, the vertex. I also have a formula for that, right? If I want to do all the angles, and I don't know by heart, I have this formula, right? Refer to your blue formula sheet. So n, take away 2, multiplied by 180, I get 3, right? So 5 minus 2 is 3 times 180. My total there is 540 degrees in total. But if I only want one corner here, okay, if I only want one corner, then you easily just divide it by 5 corners, 5 vertices, and that would give you every single corner is 108 degrees. So notice that your 72 and your 108 are totally different because they're in different locations. So you need all those concepts. Central angle compared to one interior angle. You need to know that for step 1. Step 2, draw a radius to get started. So we're going to start with a triangle, then we'll do the pentagon. So you can just eyeball that. I'm not asking you to use your compass here. So if I look at my smartboard there, I always have a habit of starting my radius on the right-hand side. That is my center, okay? That's my radius. Now I'm going to use that as a base to draw my first 180 degrees. So take your compass, your protractor, and go get 180 degrees. So in class, we go over this. I'm looking at the 0 all the way to the 120. So I'm looking at this 120 here, and I put a little slash there. Then I can draw my line, my center, and I'm lining it up, but I don't want to go on the outside. I want to go right here. So there's my first 120. Do the same thing again. Rotate that protractor, flip your paper so you don't have to work upside down. A little bit more challenging for me for the smartboard to do that. Okay, so for this one, go get a 120 again. So there's my 0. This is my 120 I'm talking about right here. So I'm going to put a little line, and then I'm going to go draw my line again. So they should be all divided into 3 perfect sections because we are going to connect and make a triangle. So every single one of this should be 120 degrees. You should know how to do this perfectly because we did circle graphs. So then I go connect on the circle. There, another one, and another one. Okay, so it makes your perfect equilateral triangle. It doesn't matter that it's kind of lopsided, but you get the idea. Pentagon. I need my central angle because I'm doing inside of a circle. So again, I want my center. I'm going to draw my first radius there. Okay, actually let me go back and just do a plain black line. I'm going to do my radius to get started, and then using your protractor, you want to go get 72 degrees 5 times. So if I have my little 72 up here, I'm going to draw another line. I'm going to join up there. There's my 72. So you want to go and draw 72 degrees like this 5 times. So I think I can rotate this. Yeah. So if I take this and go line up, so I'm just going to use the power of the smartboard here to go and get a bunch of other. So if I put a little dot there, which is hard with this here, but I have right here. And I'm going to go draw my other 72 degrees. Okay. If I use my protractor to show you again, I'm flipping it upside down. Go get the center, line up on the 0, 0 line, and then go get another 72 degrees. So 0's on the inside, 72 is right here. So I do have to keep track of that. Right, so at this point, I've done 72. I know I have 2 more sections. I can actually look at it and definitely cut that in half. They look exactly 72 degrees all the way through. So when you look at these pieces, they should look like they are 99% accurate. And then your last step, go connect. So you should have created 5 sides because you did 72 degrees 5 times to add up to 360 degrees.